Okay, good morning, good afternoon, and good evening to everyone. Welcome to our online tutorial in mathematics. Today's focus will be looking at equations, and I understand that every one of us, the majority of us, have an understanding and clear interpretation of what equations are. But today we'll be able to focus more on the types of equations and how basically we can handle each kind of equation. First thing, we'll be able to define what an equation is. Definition of an equation. What is an equation? By definition of an equation, simply saying that an equation is a mathematical statement. Is a mathematical statement that shows equality of two or more expressions. So if you're talking about it's just a statement, a saying which shows equality of two or more expressions. So usually an equation, usually the equation uses an equal to sign. So by simply saying a mathematical statement which shows the equality of two or more expressions, what do we mean? For example, I can simply have two expressions written in the form of 5 plus 3 equal to 8. This is a mathematical statement which shows the equality of two expressions, expression 1 and expression 2. These two are basically equal to each other. So this kind of a statement is simply called to be an equation. Or I can simply say 2x plus 3 is equal to 5. This kind of a statement is an equation where the left hand side should equal to the right hand side. So we're simply saying that equations always focus, or maybe we can simply say equations focuses on telling us that the left hand side is equal to the right hand side. So that is basically the interpretation of how we're able to define an equation. So from there, we'll be able to look at the types of equations. We're looking at the types of equation. We've understood the kind of equation, the definition of an equation. So we're looking at some of the types of equations. So number one, you're supposed to be able to understand how linear equations look like. So we'll be talking about linear equations, and I believe linear equations are basically the simplest equations you can look at. Linear equations basically you can simply say maybe these are the 7 type of equations. AG, where we're talking about 2x plus 3 is equals to 5. That's a linear equation. So where the degree of x is basically just a 1, that's linear. Second, we'll be talking about quadratic equations. So under quadratic equations, we're talking about this time around the degree of x is basically 2. So we're looking at equations such that we're talking about 2x squared plus x plus 2 is equal to 0. So we'll be looking at such cases which is quadratic. The degree of x is equals to 2. We'll be looking at another type of equation where you can talk about is rational equations. Rational equations, this time around, we're talking about equations which deals with a fraction. E.g., we can have 2 over x plus 3 over 2x is equal to 4. These kind of equations are rational equations. So every time which involves fractions where the denominator or maybe the fraction we have a variable somewhere there, we're talking about them being rational equations. From there, we'll also be talking about things to do with the absolute value equations. Absolute value equations. So absolute value equations, anything which is in the format of ax plus b equal to c. These are some of the absolute value equations we'll be talking about. For example, we can talk about the absolute value of 2x plus 1 to be equal to 4. and we'll be told to find the values of x in those lines. So the other thing we'll be talking about radical equations. So under radical equations, we'll be looking at emphasis on the roots. So these are equations that involves a root. So I'm sure you know when it comes to roots, or different kinds of roots, square roots, cube roots, fourth roots, and the like. So under radical equation, we'll be talking about things to do with maybe the square root of 2x plus 1 equal to 4, and being told to find the value of x. Or maybe you can have in a situation whereby you have the cube root of x plus 1 equal to 3 cube root. We know how to do the cube root. So we'll be looking at such equations later on, which are called radical equations. So, and the other thing which we can also comment on, since we understand that equations can be linear, equations can be radical, quadratics, or we can have also equations which are in the polynomial forms, polynomial equations, where in this case we're talking about equations which are more of the degree of 2. For example, you can be told to find the value of x, which is x power 4, x squared plus x plus 2 equal to 0. This is a polynomial type of an equation. So all these basically are the types of equations you'll be looking at. So we can talk about linear, which is the simplest. We can talk about quadratics. We can talk about rational. We can talk about absolute. We can talk about radicals as well as polynomials. So we'll look at each and every one of them detailed one by one and so forth. Okay, so now we are looking at the absolute value equations. Number one, I want us to define what an absolute value is. Definition of absolute value. So mathematically, if you look at the absolute value, the denotation we're talking about, the denotation to be the absolute value of x. So when you are looking at the absolute value of x mathematically, what am I talking about? This basically is just talking about is the distance. This just talks about the distance of x from 0. The distance of x from 0. Now, if I'm looking at the distance of x from 0, what do I mean? I'm talking about if I was to look at my number line like this, 0 can be at this point, and this x can maybe be at that point. So the distance from my 0 up to the x is basically the absolute value of x. So now that is why we have an instance whereby we are talking about the absolute value of -5 is basically the same as the absolute value of +5. Why? It means that if I talk about the distance from 0 to 5 and the distance from 0 to -5, the distance is basically the same. So that is why we're trying to talk about the definition of an absolute value of x to be something which can be negative or positive. So this x can be negative x if x is less than 0, and the same x which is the absolute value can be positive x if x is greater than or equal to 0. So what is the emphasis here is that if I put in the absolute value, I'm trying to consider to say all values in this case which are going to come out should be positive. So absolute value of x considers all positive values. Considers positive values. So that is why if x can be -5, once I put in the absolute value, it will still come out to be +5. So -5 in the absolute value is equal to 5, or +5 in the absolute value will still be equal to 5. Why are we simply saying so? Because the absolute value always considers positivities. So now, whatever is in the absolute value should always come out to be positive. So what is inside here just talks about the distance from the 0. The distance from 0 to -5 is the same distance from 0 to a +5. So now, with this information, it is what we're trying to use in coming up with equations. We're talking about equations now. we're simply saying that absolute value equations are equations in the form absolute value of ax plus b, which is equal to c. So we'll be solving such kind of equations later on, where we'll be looking at what is the value of x when it is equal to that. So we'll look at some of the examples which involves under absolute value of equations. So number one, we're going to solve the following equations, where we're going to say A, we're going to solve what is the absolute value of x, which is equal to 4, which is the simplest. B, we're going to solve the absolute value of x plus 1, which is equal to 5. C, we're going to solve the absolute value of 2x plus 1 equal to 6. And then D, we're going to solve the absolute value of x plus 1 to be equal to x 2x minus 1. So these are the 4 questions we're going to look at. So we can start with the first one. A, we're simply having the same information under definition of absolute values. So the definition of an absolute value says that whatsoever is under the absolute value can be positive of that or can be negative of that. So this x inside here, whatsoever we tabulate the total, whatever value we have, we're supposed to have something which is the absolute, whereby when put the absolute value should come out to be positive 4. So according to the definition, we know that this is just basically the distance from 0 to x. So x can be equal to -4 or x can be equal to +4. So once I put 4 in the absolute value or -4 in the absolute value, it will still come out to be +4. So this is the simplest of them all. Now if I look at B, where it's simply saying that the absolute value of x plus 1 is equal to 5. So number one, understand that whatsoever is in the absolute value can be negative of this or positive of that. So we're talking about x plus 1 to be equal to -5 or x plus 1 to be equal to +5. So we're solving for x in this case. This is linear, where x is equal to -5 minus 1, which is going to give us a -6. So the first value of x will be -6. What about the other value of x? We're being told that x is equal to 5 minus 1, which is going to give us a what? A 4. So now, according to this equation on B, we have that x is -6 or x is +4. Now we can be able to prove these values. Is it true that if x is -6, inserted in here, we're going to have the answer to be 5? We can prove our solution by simply saying that -6 inserted in there, I'm going to have absolute value of -6 plus 1. This should give me a +5. Is it true? We're looking at this to be 1 minus 6, which is the absolute value of -5, to be equal to 5. And we know that the absolute value of -5 will always come out to be +5, which is the same as saying +5, which I have on the right hand side. So no wonder we're talking about these two being two expressions separated by an equal to sign, which is an equation where x can be -6, which will satisfy this condition. The same is happening on 4. If I was to place 4 here, I'm going to have 4 plus 5, which is going to give me the absolute value of 5 to give me a 5, where 5 will be equal to a 5. So we're looking at C now, where C is simply saying that the absolute value of 2x plus 1 should be equal to 6. The same information as we used in B is what I'm going to do with C. So C says that the absolute value of 2x plus 1 to be equal to C. So what are we simply saying? Whatsoever is in the absolute value, 2x plus 1 should be equal to 6, or 2x plus 1 should be equal to -6. What is inside here can be +6, or what is inside here can be -6. So that we can have 2x to be equal to 6 minus 1. 2x can be equal to a 5 over 2 over 2, so that the value of x can be equal to 5 over 2 as my first value of x. And there 2x can be equal to -6 minus 1, which is over 2, and the value of x can be negative 7/2. So these are the two values of x in this equation. So we're talking about the fourth one now, where we're being told that actual value of x plus 1 to be equal to 2x minus 1. So no matter how an expression should be given, you just have to use the definition of an absolute value. So given in this case, there's an x variable in there and there's an x variable on my right hand side. So it doesn't matter. The only focus you're supposed to be able to understand is that whatsoever is in the absolute value, x plus 1, can be in two cases. X plus 1 can be the positive of 2x minus 1, or x plus 1 can be the negative of 2x minus 1. These are the two conditions according to the absolute value. Then we're solving this one in terms of like terms, where x minus 2x can be equal to negative 1 minus 1, where I can have negative x to be equal to negative 2, and this is over negative 1 over negative 1, and the value of x can be a 2 as my first value of x. The other side, I can simply say this is x plus 1 to be equal to, the negative breaks down the bracket to be negative 2x plus 1. This one goes to the other side, becomes x plus 2x to be equals to 1 minus 1. So this will be 3x is equal to 0 over 3 over 3, and the value of x will be equal to 0. So you have to understand that if 0 is in the numerator, the outcome will still be 0. But if 0 was in the denominator, the outcome is undefined. So every time we're supposed to understand that 0 should never be in the denominator, because if 0 is in the denominator, it makes our expression undefined. Okay, so now, since we've understood on what absolute value equations are, your task, you can solve these tasks and then be able to send through my inbox and my WhatsApp as the way we've been doing as always. So we have the first one, which I want you to solve, which is the absolute value of x minus 10 to be equals to x squared minus 10x. The second one you can solve is the absolute value of 2x minus 1 to be equal to 5. I believe this one is simple. And the third one we can look at is x plus 1 to be equal to x squared minus 5. So these are the three tasks I'm going to leave you with. So solve them out based on the definition of absolute values, work them out, find the values of x. After finding the values of x and the like, be able to as well prove in the situations to say, are they going to satisfy the conditions there? So after doing so, you can send your solutions to my inbox as usual on WhatsApp, and we'll be able to comment from there. Thank you very much for your attention, and see you in the next video.